So if we're looking for an angle, we have the possibility of multiple answers. Couple things to keep in mind when you're going through these. It may be possible to have 0, 1, or 2 triangles, but the thing I would write down, what you need to remember, in a triangle, sine has to be something between 0 and 1. So if you're working the problem, you get sine theta equals 1.5, you know that is not possible. So that's a case where there is no triangle. The smallest angle will always be across from the smallest side. The biggest angle across from the biggest side. And all the angles have to add up to 180 degrees. So I have basically 6 examples here, and 2 of each type. So we'll do at least 3 examples, and then if we need the next set of 3, we'll go through them. So we'll just do examples until you guys feel confident. All of these are still using the law of sines that we had Friday. So remember, we are looking at that we had A over sine A equals B over sine B equals C over sine C. So if I were to solve triangle ABC, that means find all the angles and sides. I know side A is 17.9 centimeters, side C is 13.2, and angle C is 75 degrees 30 minutes. Last week we were usually given 2 angles, so we could find our third angle first. We can't do that here. The only information we have is about A and C. So I'm going to start there. A over sine A equals C over sine C. So A is 17.9. I don't know angle A. Side C is 13.2. Sine 75 degrees 30 minutes. Right. So at this point, if we cross multiply, we get 13.2 sine of A equals 17.9 sine of 75 degrees 30 minutes. And we have to divide our 13.2 over. So calculator needs to be in degree mode. We have 17.9 sine of 75 for the 30 minutes, you do plus 30 over 60. Divided by 13.2. And it tells me that sine A is 1.3129. Is that possible? No, sine can only be between -1 and 1. So right now, if I try to do the inverse, it's just going to tell me domain error. There is no triangle where this would exist. Let's try another one. All of these are going to be the same. We're always going to be looking for or trying to solve the triangle. And I'm going to give you 3 pieces of information. Angle A is 61.4 degrees. Side A 35.5 centimeters. Side B 39.2 centimeters. So my law of sines, I have information about A and B. So I'm going to do A over sine A equals B over sine B. So side A is 35.5. 61.4 degrees. B 39.2 over the sine of B. Cross multiply. Divide by the 35.5. So we get sine of B equals 0.9649. Sorry, 0.96949. Okay, is that possible? Yeah, so we are going to get a triangle. Now, when I think about that, sine is positive in quadrant 1 and quadrant 2. So we might have two separate triangles. If I'm thinking about quadrant 1, then B is just the inverse. So if I do sine inverse, 0.96949, it tells me angle B is 75.8 degrees. But I also know sine is positive in quadrant 2. How would I get my angle in quadrant 2? (180 minus 75.8), and that gives me 104.2 degrees. All right, this is usually the point that we can check to see if both of these triangles work. All I know right now is side B is bigger than side A. So that means angle B has to be bigger than 61.4 degrees. Are both of these bigger than 61.4? Yes, so they're both possible. So now we can find angle C. So let's just deal with that first triangle. We know all the angles add up to 180, so we can do 180 minus 75.8 minus 61.4. So in that first triangle, angle C would have to be 42.8 degrees. How would I get side C? I have to do log sines again. A over sine A equals C over sine C. 35.5 with sine of 61.4 degrees equals C over the sine of 42.8. But this is like Friday's problem, so we can just plug that in. So 35.5 divided by the sine of 61.4. We're going to multiply over the sine of 42.8. And if I do that, I get side C to be 27.47 or 27.5 centimeters. This is the first triangle. We also need to check for that third triangle, or sorry, the second triangle. So we need the third angle. We have to do 180 minus the 104.2 minus the 61.4. We get 14.4 degrees. This is also the case where you'll catch it if the second triangle doesn't work. A lot of times you might get that third angle to be negative, and we know if that happens, that triangle doesn't really exist. And then we have to get side C for this triangle. So if we do that, we can do the A over sine A, so 35.5 the sine of 61.4 degrees equals C over the sine of 14.4 degrees. And if we do that, we get C to be 10.1 centimeters. So if we look, just a quick check, side B was the biggest, so angle B has to be the biggest, C was the smallest, so angle C has to be the smallest. That's true in both triangles, so we don't have any problems. Yes, it's just they would put that in for the wrong side, so it's the same side. All right, any questions on this one? So we've seen a case where there is no triangle, we've seen a case where there's two triangles. Let's take a look at this one. So I gave you angle B, side B, and side A. So we're going to have to do A over sine A equals B over sine B. So A is 19.6. So the sine of angle A. Side B 25.4. The sine of 68.7 degrees. Cross multiply. Divide the 25.4. And sine A is 0.71894. So is that possible? Yeah. So at this point, as far as we know, we could have two triangles. All right, so for our first triangle, you just do sine inverse. So second sine. And we get 45.96. So if we wanted to add significant digits, it would turn into 46.0 degrees. That's our first triangle if we did quadrant 1. We know sine is also positive in quadrant 2. How would I place that angle in quadrant 2? 180 minus 46 is 134 degrees. All right. You might catch something right now. Are both of these triangles possible? If you don't catch it yet, it's okay. But if I look, side B is bigger than side A. So that means angle B has to be bigger than A. So which one doesn't work? Since A is smaller, angle A has to be smaller than 68.7. So that one does work, this one doesn't. If you didn't catch it though, when you went to find angle C, if you did 180 minus the other two angles, we get a negative, and we know that's not possible. So the second triangle won't work on this one. So we only have one triangle to find. So to get our angle, we subtract from 180. We get 65.3. And to get our side, we can do law of sines. I prefer to use information given in the problem if at all possible. So we could do B over sine B equals C over sine C. 5.4 sine of 68.7 equals C over the sine of 65.3 degrees. So if we multiply that over, side C is 24.8 inches. Alright. So they start the same way every time. I gave you information about A and B. We have to do A over sine A equals B over sine B. Cross multiply. So we get sine to be 0.89787. So that's possible. Again, how do you know it's not possible? Right. So we're looking at our two triangles right now. Because we have to look at both quadrants 1 and 2 when sine is positive. So the first one, you just do sine inverse. And that gives us 63.9 degrees. Second one, in quadrant 2, you have to subtract from 180. So 180 minus 63.9 is 116.1. How do we get angle C? Subtract from 180. Okay. So if I do 180 minus 63.9 minus 55.3, 60.8, and then we can do law of sines to get side C. So I have information about A, so I'm going to do A over sine A equals C over the sine of C. Side C to be 25 or 24.2. Just a quick check when I'm looking at this. Side A is the smallest, so angle A should be my smallest. Out of these three sides, B was the biggest, so angle B should be the biggest, so that all looks good. Then we need to look at the possibility of that second triangle. So we find angle C. So subtract A and B from 180 and we get 8.6 degrees. And that's kind of odd. It's not a negative, so it is possible. When I'm looking, I don't see any red flags yet, so let's go ahead and find side C. Since angle C is the smallest angle, or side C just has to be the smallest side, and then we'll know we have it correct. So A over sine A equals C over the sine of 8.6 degrees. So if we plug that in, it gives me side C to be 4.1 feet. So that is smaller than the other two sides, so it is possible. So this was a case for both